Welcome to our exploration of the scientific evidence that proves the Earth is round. You know, it's funny to think that there was ever a debate about this, but hey, every scientific discovery was once a mystery, right? Let's dive into the facts that have convinced scientists for centuries, and maybe, just maybe, we'll uncover a new way of appreciating this big round ball we call home. So buckle up, space cadets, let's get spherical. We've all seen them, those breathtaking images of Earth taken from space. But have you ever stopped to really consider what you're looking at? I mean, we're talking about irrefutable visual evidence, captured by satellites and astronauts, showing our planet as a beautiful blue sphere, floating in the vastness of space. These aren't artists' renditions or computer-generated graphics, folks. These are real photographs, beamed back from space, taken by reputable organizations like NASA and the European Space Agency. They're the ultimate selfie, capturing our cosmic home in all its spherical glory. And trust me, when you see Earth from that perspective, any lingering doubts about its shape just vanish like cosmic dust. It's a humbling and awe-inspiring sight, one that underscores the undeniable truth. Our planet is round. You know, there's something magical about watching a sunset, that fiery orb dipping below the horizon. But have you ever considered that this everyday spectacle is a testament to Earth's curvature? Think about it. If Earth were flat, the sun would just diminish in size as it moved away from us like a disappearing flashlight. But that's not what happens, is it? Instead, the sun gradually sinks below the horizon, disappearing bit by bit, bottom first. This happens because the Earth's curvature gradually obscures the sun from our view. It's like watching a ball roll slowly over the edge of a table. You see less and less of it until it's gone. And just like that disappearing ball, the setting sun is a beautiful everyday reminder that we live on a curved surface, a sphere, hurtling through space. Let's head to the coast for our next clue, shall we? For centuries, seafarers have observed a peculiar phenomenon. As ships sail away from shore, they don't just get smaller and smaller. No, they disappear hull first, with the mast remaining visible long after the rest of the ship has vanished below the horizon. Now, if the Earth were flat, the entire ship would simply shrink in size as it moved further away, eventually becoming a tiny speck. But that's not what happens. The gradual disappearance of the hull, followed by the mast, is a clear indication that the ship is sailing over a curved surface. It's as if the ship is gradually being obscured by a giant, invisible sphere. And that sphere, my friends, is our planet. Ever wonder why airplanes take seemingly curved routes on a map? I mean, why not just fly in a straight line? Well, it turns out those curved paths, known as great circle routes, are actually the shortest distances between 2 points on a sphere. Think about it. If you wrap a string around a globe, the string will naturally trace a curved path. That's a great circle. Airlines use these routes to save time and fuel, because on a sphere, the shortest distance between 2 points isn't a straight line, it's a curve. So the next time you're on a flight and you see that curved path on the flight tracker, remember, you're witnessing evidence of Earth's spherical shape in action. It's geometry, physics, and travel all rolled into one. Now let's take our detective work to the cosmic stage and talk about lunar eclipses. You know, those celestial events where the Earth casts its shadow on the moon, turning it a reddish hue. But here's the thing. Earth's shadow is always circular during a lunar eclipse. Always. Why is that important? Well, the only shape that consistently casts a circular shadow, no matter its orientation, is a sphere. If the Earth were flat, like a pancake, its shadow would be elongated or oval-shaped depending on its angle to the sun. But we never see that, do we? Nope, we get a perfectly round shadow every single time, proving beyond a shadow of a doubt that our planet is a sphere. Let's travel back in time now, all the way back to ancient Greece, to meet a brilliant mind named Eratosthenes. This ingenious fellow figured out that the Earth was round, and get this, he calculated its circumference using nothing but sticks, shadows, and his brain. You see, Eratosthenes observed that at noon on the summer solstice, the sun shone directly overhead in Syene, Egypt, casting no shadows. However, at the same time in Alexandria, a city further north, a stick cast a shadow. He realized that this difference in shadow length was due to the Earth's curvature. By measuring the angle of the shadow in Alexandria and knowing the distance between the two cities, Eratosthenes was able to calculate the Earth's circumference with remarkable accuracy. This experiment, conducted over 2,000 years ago, stands as a testament to the power of observation, logic, and the enduring truth of Earth's spherical shape. So there you have it, 6 compelling pieces of evidence, each pointing to the same undeniable conclusion: our planet is round. From photographs taken millions of miles away to ancient experiments conducted with simple tools, the evidence is overwhelming and conclusive. The Earth is a sphere, a beautiful blue marble spinning through the cosmos, and the more we understand about our planet's shape and its place in the universe, the more we realize just how precious and fragile our home truly is. Keep questioning, keep exploring, and never stop looking up.